You're alive.
We're live. Well, that worked out well.
You're alive.
We're live.
You are alive.
So far, so good.
Wow, we are off to a great start. My name is Ian Trevethan.
And I am Curtis Schmidt, not
We-
Curtis Smith, as he said this morning.
Stop! It's been a rough couple of weeks. But we are here for you, and we hope that you are here for us in this time of whatever we call this now, social distancing. So, I can't think of a good segue, so I'm just going to go with birds do it. Please do it. Even educated, please do it. Hey, Curtis, let's talk about birds.
All right, hey,
How was that?
well, that was wonderful. That was fabulous.
I will never do that again. That was awful.
So welcome
I
back.
hated it.
Welcome back to you quarantines, preteens, and adults out there. Today, I want to welcome you guys back to the Flea Hardy Range, where we were yesterday afternoon talking about furry things that fly. Today, we're going to be talking about feathered things that fly, that again, are not related. So anyway,
To me, in any way, shape, or form.
this is one of our props that we like to use right now.
We present to you Corvid 16 and 17, not to be confused with Corvid 19.
Or COVID-19, or whatever that
thank you very
disease
much.
is. So anyway, welcome back to the Flea Hardy Range. I'm going to show you just a little bit about the bird collection that we have here. We've got about 8,000, give or take, skinned birds. Along with that, we've got an osteology collection, which I'm going to show you first. So we've got about 500, give or take again, skeletons and skulls of birds.
Bones!
Bones, unlike
That was-
mammals,
that
where
was
you can
Shatner.
skin the specimen and then you can have neat little beetles eat the flesh away from the bones and give you a good skull and a good skeleton as well. Birds, you either get either or. You don't get the luxury of having both. So we've got to have a skin collection and a skeletal collection. The skeletal collection is actually growing rather rapidly and has been for the last few years. The main reason is because the bulk of the people that use this collection are actually researchers in paleontology. So they're using it to compare their bones that they're finding to modern birds, basically.
Why, Curtis, would a paleontologist use a bird skeleton to compare?
Because we paleontologists don't have the beauty and the luxury of actually looking at the animals.
We paleontologists?
You paleontologists.
We.
I am French today. We paleontologists.
Oh, God.
Anyway, I digress.
Yeah.
Follow me over here. Let's look at some cool
I digressed a long time ago.
skulls. So here's just an example of the cabinets that we've got that are full of bird skeletons and skulls. Right here, as you can see, really big eyes, really big orbits. And this,
hate you.
according to the beak, is a bird of prey. So what does that tell you about the type of bird of prey? It's got giant eyes.
It's very devout.
Very devout. This is an owl. This is a great horned owl skull.
He just keeps going. I'm trying to get this guy to laugh. He's so serious about his work.
So a very cool skull, and you'll notice that just about every bird skull has ocular rings, which are basically bony elements that support the eyeball. And again, for this guy right here, very, very large eyes. Very good for seeing at night, which is what owls do. They hunt at night.
So, back to my question before I interrupted myself. Back to why a paleontologist might use a modern bird osteology collection. And I was actually just, believe it or not, having a serious discussion with Curtis about what we call the extant phylogenetic bracket of the dinosaurs, which is a really, really, really fancy term for saying the modern relatives or the modern bookends, if you will, of dinosaurs, which are the crocodilians and the modern birds, or avians as we call them.
We refer to those groups as archosaurs, which are the same group, I believe, as dinosaurs.
You are correct, sir.
So, these are living modern dinosaurs, if you will, and very closely related to modern reptiles. In fact, as Ian just alluded to, the closest living reptile to a bird is a crocodile, actually. So if you want to continue moving down the row here, this is a sandhill crane skull that you're looking at right now. Very interesting skull. You can see the differences there. Long beak. And we're going to go into this here in a little bit. You can usually tell by looking at the shapes and the sizes of the beaks, as well as the feet, where these animals live and what types of organisms or things that they eat. Moving down here, this is one of my favorite skeletons right here. This is a belted kingfisher, and if you'll notice, it looks like the skull is way too big for the body, which is one of the things I really like about it. If you've ever seen a belted kingfisher, they're a relatively small bird, but they swoop down and pull fish right out of the water. Very, very interesting birds. We're going to skip down here to the bottom right here. See if anybody can guess what this is, even though I can't see what you're guessing or hear what you're guessing, but I imagine some of you can. This is a pelican skull. And this is only the top. This is missing the mandibles down below. So that's just the top of the skull. Now I'm going to pull out this little guy, and hopefully you guys can get a good view of what we're looking at here. So this is the skull of a woodpecker. And one of the most unique adaptations of a woodpecker skull is its hyoid bone, which is what attaches to its tongue. And if you look at it, there's two sides of the hyoid bone that would attach to the tongue right inside the mouth. And the fascinating thing is they wrap all the way around the skull. So all the way around the skull, terminating in the nostril. Absolutely bizarre. Now there's muscles that attach to this hyoid bone and allow this woodpecker, once it pokes a hole into the tree or whatever it's prodding into, to project its tongue really, really far down deep into that hole to pull out whatever it's poking and prodding for. Very, very fascinating. If you don't find this fascinating, boys and girls out there, I don't know what's wrong with you, and maybe you should get back playing your video games.
God, you sound like an old man.
No, I'm just kidding.
Get off my lawn.
I only said that because these guys play video games. So, fascinating skull of a woodpecker. And yes, all woodpeckers have this very extensive hyoid
verified that Curtis Schmidt's first words were "get off my lawn." Jeez. I'm not going to hang out with him during this whole
it's just fascinating stuff.
Chase me out of his office. Get away from me, you whippersnapper.
So the next thing I want you guys to see is we're going to kind of show you a tour of just kind of some of the things that we have in our ornithology or bird collection.
Hang on. Before we move on, there's one more thing, sort of as professional as I get, that I do want to sort of tie back to paleontology, zoology, birds, and archosaurs, is one of the things that we use to, I guess, connect these seemingly very different animals together is the features of the skeleton, and they are features in the skulls. So, you know, for example, T-Rexes have basically what we would call a wishbone. So do birds.
A furcula.
A furcula is what we call them. And that's a fun word to say, furcula.
Be careful out there.
Furcula. So, I can't remember what I was going to say now. It was really good, though.
Tying these animals together using osteology.
Yes, thank you very much. So that's kind of how we find ourselves figuring things out that we can't answer necessarily in real time about some of these extinct animals. So I just wanted to throw that in there just in case there were any sort of lingering questions of, wait a minute, how do you get from a bird to a dinosaur to a crocodile? How are they all archosaurs? Well, the answer there is similarities in the skeletal structure.
There's also similarities in the internal anatomy as well, like the heart of a crocodile is very, very similar to the heart of a bird.
as well as like spaces within the bones, air spaces, things
Right.
like that.
Right.
So that's kind of how we tie these animals together and, at least in part, figure out their relationships.
And some paleontologists, including the main paleontologist that we have here, Dr. Laura Wilson Brantley, she studies bone histology of fossils primarily, and she studies fossil birds. So one of the things that she uses this collection for is to look at the histology of the modern bird collection and compare that to the histology that she's seeing in the fossil collection. So that's one example of the variety of different things that you can study as a paleontologist looking at a modern bird collection, things like that. So if you can ignore the banging that's going on in the background, hopefully you can't hear that, but we have a lot of construction going on.
We do have a question before you move on. What do woodpeckers mainly eat?
Woodpeckers eat a very large variety of things, but primarily small insects. So they're eating beetle larvae that are underneath the bark and inside the wood of trees, which is very good because a lot of those are pests on the trees and kill the trees. But I would say most of the time they're eating insects. Even if there are a couple species that are mostly on the ground, even they're not in trees most of the time, they're feeding on grasshoppers and things like that. So mostly insects. Good question. Soft-bodied insects for the most part. So as I was getting ready to do before he so rudely interrupted me, I'm going to just show you a variety of some of the things that we've got in the collection, tell you a little bit about why, and then we're going to go through some examples of what I mentioned before, some of the feeding and how you can tell where a bird lives and what it eats, often based on the structures of its bill and its feet. So before we do that, I like this drawer right here because it shows variation, which is one of the reasons why we put together series and collections like this, is to look at individual variation. And if you'll notice, every one of these specimens has a tag with a number on it. It tells whether it's a male or a female, tells how fat it was when it was collected, tells exactly where it was from. So just a little bit about collections in general. That's probably the question I get the most is, why do you have so many of the same thing? But if you think about how these things are collected over a very wide geographic area and over an immense amount of time, they're not all collected from the same place at the same time. That's a bad way of thinking about it. So they're from all over the place from a lot of different times. So putting together collections like this is our way of showing and keeping a permanent record of what lived at a given place at a given time. Okay?
Variation studies are really cool. I could go forever thinking about how variation works, how much variation can occur before you end up with something completely new, and where they lie. It's kind of what keeps, at least our kinds of scientists, going, is this sort of excitement of how do you define, how do you understand how things change over time. And this kind of collection is a really wonderful way to do that because you get so much individual variation in such a wide range. So we have a really good idea of how to sort of categorize these things.
So with a lot of birds, basically we're looking at how sexy the bird is, especially if it's a male. Because the whole purpose for being an organism is to spread your genes and reproduce as much as possible. So male birds in particular are usually the ones that are very, very pretty, very colorful. And when we're talking about variation and you're looking at a series like this, you can pick out what you would consider to be the sexiest male. And imagine if you're a female trying to pick out the sexiest male, this guy is going to spread his genes a lot. Because he has, he's very colorful. He has a nice, big, black bib. And just very vibrant colors. So basically what this signals to any female is he's got a really good territory. He eats very, very well. He's a very healthy animal, doesn't have a whole lot of parasites, and he's mature. Because another thing you can study looking at a series like this is ages and the different age groups and how they change from juvenile to an adult.
So imagine trying to figure these things out with only fossilized bone. So again,
Impossible to do.
this is why a lot of paleontologists will refer to zoological collections. So we can sort of see how these things present themselves, and then we can see some variation in fossil bone, but it's a little bit harder to interpret. But we do have to take these things into account. How old are they? Are we naming species for growth stage? Are we looking at what could be true sexual dimorphism? Are we looking at size differences based on the sexes? So it's good to be very clear about how variation works in this kind of animal.
Right.
Where are these birds native to?
These are actually Bullocks orioles that are mostly native to the southeast U.S. or southwest. I'm sorry, the desert southwest. But they do make their way into western Kansas. So not too common in this area, in the Hayes area, but further southwest they become pretty common.
And we have another question. What is your favorite bird to learn and discover new information on?
Holy smokes. Well, I'm not an ornithologist for one, so forgive me because I'm stepping out of my comfort zone. I'm certainly not an expert in birds. So I don't really know what my favorite bird to study would be.
Birds are just cool in general.
What's Dr. Fink's favorite bird to study?
The dick sissel. He refers to it as God's favorite bird. But anyway, I would say my favorite birds are penguins. I really, really like penguins. I think they're fascinating because they swim underwater. Have I studied them? No. Have I ever even seen one outside of a zoo? No. But they are my favorite birds. But anyway, I digress. Let's move on to another series of cool little birds to showcase a little more variation. So these are yellow warblers. These are a migratory species. So again, look at all the variation within all these individuals. Pick out which one, if you were a female, which one is going to be the sexiest bird to you.
Curtis, you will always be the sexiest bird to me.
Oh, you're too kind.
This one. That one.
Look at the color on that one. It's bright red.
Yeah, I lost my feathers a long time ago, though.
Well, it happens to the best of us. It just means you're mature.
Moving along, so this is a species of woodpecker that we've got in this area that's very common. This is called a northern flicker. And interesting with these guys is they come in two different races. They have a yellow shafted flicker, which is the one on the left, obviously, and a red shafted flicker on the right. A really interesting thing about that is typically they do not interbreed, but they are subspecies of one another. They're the same species, just two different subspecies. But where they do come into contact, they do interbreed and they become orange shafted flickers. So very fascinating there.
So that would sort of to, I guess, somebody just starting out and exploring individual variation. This could be something that would be enlightening and maybe even a little confusing to try to figure out, to try to track that.
Right, and actually to find an orange shafted flicker is not very common. You don't see them very often at all. So this next cabinet over here is just kind of a example of some of the worldwide things that we have. So with most of our collections, including the ornithology collection here, they are Great Plains centric. So just about everything that we have in the collection are from the Great Plains, which makes sense because that's where we're located. But we do have secondary collections of things from throughout the world for mostly comparative purposes. So we can see what the things look like and we can make comparisons. So we don't have a lot. So this is our only drawer of parrots and parakeets for the most part. But again, we have drawers upon drawers of yellow warblers.
So going back to beak shape, parrots and parakeets have great shaped beaks. Very different than a woodpecker or a raptor kind of bird. Can't remember what I was going to say. Oh yeah, the shape of the bird beak Words are hard. So these guys are pretty much seed and nut eaters.
Correct.
And these beaks are good for processing, cracking open the seeds to get to the pulp.
Strong, thick, powerful beaks for crushing and cracking open nuts and seeds. And we'll get more to that here in a little bit as well.
Some are ground feeders, and some I assume are arboreal or hanging out up in trees.
Right. Wherever they can get a nut or a seed to eat and crack open, that's where you'll find them.
There's lots of those in the museum.
Lots of
Lots of nuts in the museum.
Here's a question that you're almost standing under, I think. What's the biggest bird you have in the museum?
Oh, I'm about to show you those as a matter of fact.
Exactly. That's where I was getting to.
So I love to talk about this drawer right here for a couple different reasons.
Good
So
timing. with that
these
question.
right here, if you have any guesses out there, these are eagles. Now most people guess that these are golden eagles, but no, that's not true. These are actually all three immature bald eagles. It takes bald eagles at least 2 years to get into the coloration that we're used to seeing with the nice bright white head, the white tail. So they keep this juvenile coloration for about 2 years. I also like to point out the feet, if you can zoom in on that. These talons are really, really sharp, really powerful feet. So these things are really good at killing just about anything small enough for them to pick up and eat. And they're going to have that raptorial bill, that beak for shredding and tearing apart flesh. But this is just a good indication that you do not want to get attacked by one of these things. It would not be pretty.
Those are some pretty cool feet.
A lot of people also ask, well, isn't it illegal to have bald eagles and eagle specimens in a museum? Yes, it typically is. You have to have special permits for it. But I also like to point out the fact that these were collected in 1960 and 1961. So that is long before the Endangered Species Act, so these things were not protected. None of the birds were protected at that point in time. Most of the birds now are protected by the Migratory Bird Treaty Act, so we can't kill any of these birds because they are migratory birds. The only ones we can kill are the ones that we can actually get hunting licenses to shoot. So that's one of the things I like to point out is these are pre-Endangered Species Act because they are so old. And also I like to point out that you look at these and these do not look like they were collected 50 years ago or whatever it may be. My math is terrible. Anyway,
60.
so it's a part of my job to make sure that these things stay preserved forever. As the zoological collections manager, that is my primary job. So I have to make sure pests stay out. And by pests, I mean flesh-eating insects, things like that. Because if little beetles and moths and things get in there, they'll quickly eat anything that's carbon-based. So they can eat the feathers, they can eat the flesh that's remaining. And basically all this is a stuffed bird, stuffed with cotton. The skull's still in it. Some of the bones are still in the feet and legs. But other than that, pretty much everything's gone, just stuffed with cotton.
So we've got a couple of questions. One that's kind of pertaining to this. So how do you get modern birds? How did you get these birds specifically, and then how do you get birds
Sure.
today?
So it's very, very difficult to be able to scientifically collect bird specimens, but you can get permits from the U.S. Fish and Wildlife Service to do it. So we have to have a federal permit from the feds, and then we have to have a state permit to collect as well. And again, these things are not easy to get. You usually have to have very specific research questions you're trying to answer. But if you do, and you have a good proposal, and you give them the evidence that you're doing it for a good reason, they will usually grant the permit and allow you to do it. And if you were here yesterday listening to how we capture bats for research, that's the same thing we do for birds. We use large mist nets. They fly, they can't see the net. They get stuck in it, fly into it, we collect the bat. And oftentimes we band them, just like we do bats, as I was telling you yesterday afternoon.
I did some bird banding in graduate school.
Right, and so did I.
Yeah.
So there's a wealth of information we can get from the birds that we capture, and then we band them and release them again. And then we track them year after year, see if they come back. Because a lot of these birds are migratory. They go a long ways for the winter, and then they come back to the exact same spots very often. So it's pretty interesting to be able to track that using the different band combinations.
And that's sort of helpful information as well on the paleontological side, because we hypothesize that some of these animals that we are observing in the fossil record very well could have been migratorial like modern day birds.
Without a doubt, I'm sure they were. Walk this way.
Walk this way.
As we're answering questions.
Don't we get a lot of birds from flying into windows and things?
Yes, we do as well.
So do you take birds that you just find dead on the ground?
Yes, I do. I actually do have a federal salvage permit. The museum does. So anybody that finds one and wants to turn it in, we usually turn those into our osteology collection. So we'll feed those to the beetles basically, and have them cleaned and have the skeletons cleaned. But yes, that happens very, very routinely.
I would imagine generally a salvage specimen is not in that great a shape. I mean, I guess it depends on the circumstances.
They're because they fly and they are so lightweight, their bones are very, very fragile. Usually they snap their neck before anything happens. So they actually do come in relatively good shape and very good condition. They snap their neck, they're dead, but they do that without, damaging the skull and bones and things like that. So what we're going to do here is I'm going to go through some examples of feet and beaks. Okay? So a lot of you will probably recognize this guy. This is a mallard drake, which is a male mallard.
Not to be confused with a mallard jake,
who is standing behind the camera right now.
Hi.
So these birds are considered dabbling ducks, so they don't dive underwater. These are the ones that you see with their rear end up in the air as they're foraging underwater.
nothing wrong with that.
Nothing wrong with that at all. Before I get too in depth, I want you guys to look very closely at the feet. And this is another way that we can see that these things actually have reptilian ancestors. These are actually reptiles because they've got scales still. And this is true for just about every bird. They've got scales on their feet.
Well, and if you recall, we were just looking at those raptor-like feet, and I was thinking to myself exactly what you're saying. How can you not see that these animals are dinosaurs?
Right, for sure. So that is one of the easiest ways that we can say that they are actually reptiles. Now, ornithologists will not jump into the category of herpetology because they're just stubborn that way. So they're going to continue to study things on their own, which is just fine for us herpetologists because we don't want to study birds either. So these guys right here are generalists. They eat just about anything. So basically they can almost chew with their beak that has serrations in it. They don't have teeth. They're not true teeth. And hopefully you can see that. But these guys are both vegetarian and carnivorous, so they're omnivores. They're eating plant material, they're eating insects, they're eating crustaceans, basically any little critter down in the water, algae, things like that. And if you're a hunter and you know much about ducks, where do you often shoot ducks outside of water? In agricultural fields. So they're in the fields, they're eating a bunch of grain and things like that. So that is a generalist. And again, if you look at those feet, you can't see them very well in this one, but they have very highly webbed feet, lobed feet for swimming. Very good swimmers.